Good afternoon, everyone. Today we're going to be talking about solving linear quadratic systems. So basically where a line and a quadratic or parabola would intersect. Okay. And we did sort of introduce the idea a little bit of how to do this. In yesterday's note, we had one example asking where the two parabolas intersected. Okay. So same kind of idea here. Before we start solving some problems, I'm just going to show you a little demo on Desmos. Okay. So just like with equations of lines, right, you had when they intersect, either they cross or they're parallel, right? There's some different options there. The different options for a parabola and a line. So right now, they cross twice, right? There's my 2 points of intersection on my graph. Okay, as I play with the slope, right, they still cross twice, still cross twice. Okay, okay, I've kind of hit a wall here on my slider, but it could go further. Okay, I'll flip back around the other way. So somewhere along here, okay, and it's hard to hit, okay, but you can see, if I zoom in a little bit here, okay, right, there would be a point where they would just tap once. Let me make this a little bit smaller. Right, I can get them really close together. It's still not letting me do it. But yeah, if I do something like 0.45, okay, something like that, right? It could just tap the parabola, okay, and intersect it only once, okay? So yeah, you could hit it. It could just kind of hit it two spots. You could hit it once, okay, or it could miss it completely, okay, and be zero. Actually, as I push from the other side here, looks like I can kind of cozy up there, maybe touch it once again near the top of the graph. Okay, so our possibilities for intersection are twice, once, and not at all. Okay, all right, so here we go. Determine the intersection of the parabola f of x is x squared minus 3x plus 4, and the function g of x is negative 3x plus 8. But the idea of solving this is going to go right back to what we were doing yesterday. Okay, well, if I want to know where they cross, that means that they would be equal to each other somewhere. So I just start with that f of x must be equal to g of x. Third on my equation, x squared minus 3x plus 4 equals negative 3x plus 8. Okay, now we're going to do what we did yesterday, right? If I want to solve a quadratic equation, I get all my terms on the same side, and then solve the resulting quadratic. Okay, so I'll bring these over. So x squared minus 3x plus 4, okay, plus 3x, and then minus 8 equals 0. Okay, collecting my like terms, I have minus 3x and plus 3x, so they're gone now. So I have x squared and plus 4 minus 8, that's minus 4 equals 0. Okay, so now I just need to solve my equation. So I can either rearrange it, or if you know how to factor that, it's a difference of squares. So I have x minus 2 and x plus 2. Okay, so that means that it crosses at minus 2 and 2. Okay. Last but not least, I would probably really want to know what my points are, right? So I need to go back to one of my functions for each of these and plug it in. So let's say if I was using the equation of my line, is a little bit easier to work with. So if I do g of negative 2, that would be negative 3 times negative 2 plus 8. What would that be? 6, 14. Okay, so one of my points is negative 2 and 14. Similarly, if I plugged in positive 2 into my equation, I would get, I think, the point 2 and 2. Okay, so my other point is 2 and 2. And those are my solutions to the original question. Okay, so that's pretty much all there is to it, to solving one of these. Okay, is just, right, set the parabola equal to the line. If they're both in that y equals or function equals form, solve for x, and then figure out what your points are. Okay, so let's try it again. Okay, almost the same thing, just slight tweak there, a slight tweak. Now my line is negative 2x plus 8. So this could be a good place to pause the video and let the class try this on their own for a few minutes and see what they come up with. Okay, but hopefully now you're back, and I'll just run this through. Okay, so again, these are equal to each other, right? F of x equals g of x. So x squared minus 3x plus 4 equals minus 2x plus 8. Okay, bring things over. So I'm going to speed this up a little bit and combine the like terms as I go. So I'm going to have x squared. When I bring over the negative 2x, I'm adding it in. So that's minus x. And then I have minus 4 equals 0. Okay, so we attempt to factor, but multiplies negative 4, adds negative 1. That's not going to work. So we will go to our friend, the quadratic formula, instead. That's what I hope you had to do if you tried this out already. So I got 1 plus or minus square root negative 1 squared minus 4 times 1 times negative 4 all over 2 x equals 17 over 2. Okay, so you can have 1 plus root 17 over 2, or 1 minus root 17 over 2. Okay, so again, we got our x values. Now I need to get my y values. Okay, so just for practice sake, let's try to keep this exact for a while. So if I want to find out my y coordinate of my points, I got to go into my function. So let's say for this one, I have to calculate g of 1 plus the square root of 17 over 2. Okay, so that's going to be negative 2 times 1 plus root 17 over 2. I think was plus 8. Yep. Okay, now thankfully this works out kind of nice here. I have 2 divided by 2. So I've got negative 1 plus root 17. So this should be minus, shouldn't it? Minus root 17. Okay, and then plus 8. So I have 7 minus the square root of 17. So one of my points is 1 plus root 17 over 2 and 7 minus the square root of 17. You know, if we were going to graph this, we would just get the decimals and see what's going on. Okay, but there's the exact solution for that point. Okay. Similarly, if we do the other one, my other point is going to be 1 minus root 17 over 2 and plus the square root of 17 over 2. Okay, that's pretty much the whole process right there. So, a couple more little things. First is, okay, just to do a little more problem solving here. Okay. So one more time with that same parabola or similar setup here. Okay, determine a value of k such that this parabola and the line negative 3x plus k intersect just once. Okay, so where should I set up my line so it just barely grazes past the parabola? So we should have the idea this by now. Let's set them equal to each other. F of x equals g of x, x squared minus 3x plus 4 equals negative 3x plus k. Bring everything over. Okay, so we have basically x squared three x's are going to cancel, so plus 4 plus k is equal to 0. Okay, so what we do from here, okay, if they're only going to intersect once, okay, so that was my goal, to see if they intersect once. Well, that would mean my solution to my quadratic would only have one solution, okay? I only get one thing. So this is tying into the discriminant, okay? So what should my value of k be such that I only get one solution here, okay? So we're going to write out our discriminant, which is b squared minus 4a. Okay, and if I want to have only the one root, that should be equal to 0. So we're going to plug in what we have here. Well, I don't have an x term, so my b is 0. Okay, my a is 1. And my c, okay, this looks a little weird, but this part here, actually this should be 4 minus k, shouldn't it? Okay, but that's my constant, is that part out there. It's just 4 take away k. And that would be equal to 0. Okay, so let's start solving this out. Okay. I've got 4 times 1, so 4, and then times my bracket. So I've got 16 minus 4k is equal to 0. Okay, bring over, let's say we bring over the 4k. So 16 equals 4k. Divide both sides by 4. So 4 is equal to k. Right, so my value of k is 4. Then I only get one solution. And if we pop back up here, that would kind of make sense. Okay, if I plugged in 4 at this step here, I'd have 4 minus 4, that's 0. And I just have x squared equals 0. So the only root would be 0 to that system. Okay, so that's how that works. Okay, a final little note before we put up the practice work is that the other day, in talking with people while they're working on their practice work, okay, a question was asked about quadratic formula a little bit, or how to maybe some simplifying. So just to show you what I'm talking about, let's say you were working on something, okay, and you had to use quadratic formula, and you got to a point where you were maybe at, I don't know, x equals 8 plus or minus the square root of 20 over 2. Okay, that's what you got it down to. Okay, and you check in the back of the book, and it says something different. Okay, I'm going to show you how you can tidy this up a little bit. Okay, it's going back to the radical stuff, right? I can simplify the root 20 using the rules that we had from radicals. Okay, so on the side here, say, well, that is really 4 times 5. So square root of 20 is the same as 2 times the square root of 5. Okay. So I go back here. So now I have 8 plus or minus the square root, pardon me, I want to change that to 2 root 5 divided by 2. Okay, how does that help me? Well, I can tidy this up a bit because now both terms of the numerator, okay, are divisible by 2, and it says to divide this by 2. Okay, so I go through, I can divide each thing on the top by 2. So 8 divided by 2 is 4, and 2 divided by 2 is 1. So what this is now reduced to, this is equal to 4 plus the square root of 5, plus or minus. Okay, so I have reduced my quadratic formula using simplifying radicals to something that looks a little bit nicer. Okay, I've been able to take the fraction out because I can reduce it. Okay, that's the whole idea right there. It's just now that we know a little bit more about radicals, okay, I can tidy up the quadratic formula a little bit more and make it a bit neater sometimes. Doesn't always work. Okay, if I flip back to our second example there, okay, right, I had the square root of 17. Okay, right, 17 is prime, so I can't do anything with that square root. Okay, but something like this, I potentially can clean it up a bit. All right, so there's your practice work, okay, for this section, starting on page 198. Okay, thank you very much for watching, and I will see you tomorrow.